Lab report, did you type F equals MA anywhere in the report? I would hope so. I'd hope so. You didn't do a whole report on Newton's second law without mentioning F equals MA.
Yeah.
Are you sure you did?
You have to state F equals MA, or can you say force is the product of...
That's okay, but for goodness sake. I know, I'm getting angry. Yes, and the graph, you didn't have enough points on it. Yeah, I know, but for the graph you can make more points to make a smooth graph. Because you're only using 10 in task 2 and 3, but task 1 you can use as many as you want. You tried to tell him this?
Yeah, go to.
And, yeah?
It's okay if we not use many points.
Yeah, just more than what... His graph looked like it.
Yeah.
I did. Yeah, you need more points. Yes?
what time should we submit tomorrow?
In class, in maths class tomorrow.
Maths, not physics. We have physics first.
Yeah, in maths, we'll keep it fair, in maths.
So
this is
okay, only have 10 points in question in stuff in
The graph.
B and C.
In which task?
1, B and C.
No, I'll give you more marks if you have more points on the graph. What I want is a nice... No, just really for the triangle graphs. I want a nice, smooth, exponential graph. I don't want it sort of, jagged. I want a smooth graph, as much as possible.
It's the only graph anyway.
Yeah.
Triangle graphs are the only graphs.
That's true, yeah. But maybe somebody wanted to make a graph in task 2 that demonstrates the trapezoid, but I mean, I'm not expecting that, because that sounds like a lot of work to draw 10 trapezoids, you know, so it's just task 1 that I want the graph in. Okay, we'll continue with physics. Now, I think the way we left it was to do some questions, correct, yeah, so let's just open that up. Yeah, it's a backup of my phone. All 5 megabytes of it. Whoa!
Do you need a floppy disk for it?
Like 3 of them. Right. It's been a long time since I used a floppy disk. I mean, I'm surprised you even know about floppy disks.
Come on.
Everybody does?
Yeah, you studied them. Not
You
everyone
studied them in history class, was it?
We actually studied them in IT.
Yeah.
Did you?
Yeah.
And
Really?
Yeah.
Weird. Oh, primary school. Okay, well that's not so weird. Advantage. You can use it as a coaster for your tea. In emergencies, it can be used as a weapon. Yeah. That's such a nunchuck.
Now they make it sunglasses.
Yes, that's such a. I think I have examples to do. Is that correct? And then the tutorial on this, because we did Faraday's law. So let's have a look. We did this. We did this. We did this. We did this.
No, we're here.
Yeah, we did. Well, we mentioned this. So yeah, first example. If you can write this down, please, and then I'll do it. You can write or draw. What's that? Oh really? How nice of you. Thank you. You can draw this if you want. It's very similar to the first diagram we had in the lesson. Okay. Did you write that down? Confused? What word, Fuan? No, tell me, what word? Come on. Fuan! What word is confusing you? Please tell me.
Wrapped.
Wrapped, yes. Wrapped is a verb. It means to go like this. You know, like, here, like this. This is wrapped. Yeah. Okay, did you write that down or draw it? Yeah. Can I do it now? Yeah. Okay. So firstly, let's just draw what we have. How wide is this pipe? It's 5 centimeters, okay. And how long is it? 30, good. And then I think the wire is wrapped around 100 times. Is that right? Yeah. So it goes around, obviously I won't draw it 100 times, but just so you can have the picture. Uh, 100 times. And you have a magnet, and the magnet here, north, south, and the magnet, you bring it into and then bring it out of the cylinder. So what's happening? The magnetic field is changing. Why can we say it's changing? Like, it's the same magnet, so why am I saying the magnetic field is changing? Because you're moving it, yeah. So it's kind of like this. At the very beginning, if you were inside the pipe, there would be no magnetic field inside the pipe, correct? Because the magnetic field is outside the pipe. Then what happens as you move the magnet in? It comes inside it, and then you have a magnetic field. So Faraday said, because the field is changing, you'll get a voltage, yeah?
Does this mean we can make a negative value for the magnetic field?
The magnetic field could be a minus. It depends on which way you're moving it, yeah. So the sign I don't really care about, because I don't care about the direction of the voltage. I just want to know how much voltage it is. So I won't care about the sign. And the formula is N times the change in the flux over the time. Now, did I give you the time? 3 seconds. Okay. And here, flux is density times area. What is changing here, the B or the A? The B. Because the area is not changing. So this would be 100 times, the time is 3 seconds, and what I'll do actually, this is A, change in B over change in time. Because only this one is changing, not the A. Only that one's changing. So I'll just put the A here. Let me write in here. Pi r squared. 100 pi, r squared. And then here, what's the density of the field? How many Tesla?
1.5.
1.5. Okay, so if we hit that in, please. Now, what was your question, Yahya?
But then the change in flux is over time, so how will it make a difference?
If what, yeah?
Is that dA equals to the change in flux?
Yes.
So why can't we just put A?
Explain again.
Why can't we put AB over time? Why do we have to take the A out?
Oh, no, you don't. No, you don't. You could multiply the A by B and leave it in the brackets. That's fine. The only reason I took the A out is because it doesn't change. It's a constant, so I factored it out just because it makes it less to type on the calculator. No, but you're wondering why is the A out here and not in here? It can be. Right, so what voltage did we get?
0.93. 393.
0.393? Yes.
The radius would be 0.00.
Oh, thank you, sorry. Did you? Yeah, sorry. So this is 4 times too big. So it's roughly about 0.0 0.1 volt about, roughly.
Yes.
Yeah, so about 0.1 volt. Now, can I go back to the question? Is that everything? Just the voltage? Yeah. Okay. So that's okay. Now here's an interesting one. A plane takes off heading towards Santa Claus at the North Pole. The magnetic flux density for the Earth is 0.07 millitesla. The wingspan of the plane is 68.5. And the climbing speed is 600 meters per second. What is the direction and the size of the induced EMF in the wings? So, let's just think about this. Is it left hand or right hand?
Left.
Right. The last rule we did. Yeah?
Fleming's right.
Yes. Yeah. So, let's just picture this. Here we are. The north is that way, the North Pole, Santa Claus. So which way is the magnetic field going?
There.
That way. So this finger points that way. Now, what way is the force? If the plane is taken off, which way? Up. So that is correct. So which way will the current be in the wings?
Left.
To my left. In other words, to the west.
Yeah.
So as the plane is taken off, there will be a current that runs to the west in the wings. And we are going to calculate this. Okay? So, if you can write down the info, and we'll calculate it now.
When do we use the left and when do we use the right one?
Good question. Right is for when you are inducing a current. Left is for when you are using a current to make a force. So in other words, right is for generate power. Left is for creating force.
Left is when they ask you what is the force, right is when they ask you where is the current.
Roughly, but not necessarily.
Yeah.
No, not necessarily, because I could have phrased the question here. I could have said a plane is heading towards the North Pole and a current is induced towards the west. Is the plane landing or taking off?
Oh.
Do you like that now?
Mm-hmm.
So then that means you have to decide,
Yeah.
is it this way or this way?
Right is for generating
Yeah.
current and left is for
Generating a force. Okay. Do you have the information?
I'm sweating from under my glasses. That's how hot it is. And from other places, but
This is the socially acceptable place to mention in class. Thank you for your consideration. Your manners have improved greatly. If you need water, go get it. You're not in Ramadan right now, unless you're doing Ramadan Plus or something, the extended version, director's cut.
You can't do it on Eid. It's still the last day of Eid.
you only can do it in the first day. Andrew?
No, you can't.
You can.
No, even the other days you can.
Second day you can. No. Yes, you can.
Yes,
First 2 days you can. First day you can.
Hang on, no religious wars in my class, please. Please. This is a place of physics. Alright, did you write that down?
Kill your land and kill your people. Go ahead.
Just tone the Arab thing back a little bit, please.
What do you mean?
Make
You
me
mean
very
something?
Start unbuttoning his shirt.
Dude, too soon. Alright. Okay, do you have the info down for this? Yes? Now, this one is a little bit harder than the last one. So firstly, let's have a look at Faraday's law. I don't care about the sign, so let me just make the
after
plus.
Friday or before Sunday?
What?
Friday.
You can do better than this.
They both met after Friday.
What?
Never mind.
Yes, indeed. Right, so first question. The n. What do you think the n is here? 1, correct. Why? Just the one wing. Yeah. So let's forget about the n. Now, the big question here is, which is changing, the B or the A?
The B.
No, the A. Why?
When it's changing the thingy, the more air is hitting the surface. So the more electric field is hitting.
Basically, the B isn't changing because that's a constant for the entire Earth. What is changing is as the plane is taken off, there's an area being drawn in the sky. You know. Now these questions are difficult, and to me it's difficult because it's not clear which is the thing that changes, the B or the A. But as a rough rule, the problems where they talk about moving a magnet, those are the problems that deal with the B changing. Everything else is probably an A. Okay. So here, this will be B, change in area over change in time. What did I say the B was? 0.070 milli over change in area over change in time. Now let's make our life easy and look at it. Look over 1 second. See what happens in 1 second. What voltage do we get induced? So over a period of 1 second, then we just have to look at how the area changes. Now we kind of know that. If we picture, here's the ground. The heck? Spelled ground with 2 G's. Right, here's the plane. We're looking at it from the side, and the plane is taken off. And I don't really care about the horizontal speed. In the question, I give you the vertical speed, which is, what did I say it was? 600 or 300? 600?
Yes, 600 meters, so maybe it's not.
No, sorry, 600 is a ridiculous answer. Why did I pick 600? Yeah, tell me why a taken off speed of 600 meters per second is ridiculous.
Because they're not as fast as me.
Well, could I have a real reason, please?
Oh, that's faster than sound.
It means the plane is taken off at super speeds. No.
Mach 2 speed.
Yeah, Mach 2.
So,
that would be an impressive takeoff speed. We need to pick a different number.
I don't think it's possible.
No, it's not possible.
It's a bit dying rather than...
Exactly, it's not possible. What would be a reasonable taken off speed?
not even 300.
No, not even
Vertically,
300. Vertically?
Yeah, vertically is not even 300.
100.
I think
150.
100, we'll say. We'll say 100 meters per second. So that means as the plane is moving up in the air, each second the area increases by 100 meters vertically. Now why don't I care about the horizontal? Because for the current it's only in the direction perpendicular to the field, so we don't care about the horizontal. So it means we have 0.070 times 10 to the minus 3 times 100, which is 0.070 times 10 to the minus 1, which is 0.007, which is 7 millivolts. So that is how much voltage is across the wings of the plane as it is taken off. But when the plane is at cruising speed, cruising altitude, there's no more voltage. Why not?
Because there is no force upward.
Well, there's still a force upward, but there's no movement upward.
Yeah.
So what part of the formula is zero? The area. The area is no longer changing. Yeah. The plane isn't moving in the... There's no more of this F movement. Yeah, parallel to it. Yeah. So nothing happens then. So as the plane takes off, it has 7 millivolts induced every second. But then as soon as the plane reaches a cruising altitude, that voltage drops to 0. So if you think about it, it actually provides an interesting way to work out if the plane is landing or taking off. You know, if you imagine, here's the plane.
UFO, you mean?
No, I'm looking at the top, okay? Look, you know what a plane looks like. There, okay, better? So as the plane is, this is north, south, east and west. As the plane is taken off, you'll get a voltage running this way of 7 millivolts. This is the tail here. But when the plane lands, the direction changes because the force changes, and you'll have it running this way. And when it's at cruising altitude, the voltage drops to 0.
What was doing this?
Yeah, it'll switch. You'll have an alternating current along the wingspan.
Could you repeat that, the line?
Not really, because it's not something on the exam. It's just something that's interesting.
If it's going up,
The voltage will be to the west.
yeah, from
Then if it's going down,
From east
the
to
voltage will be to the east. Okay.
Can you go back to the copies?
Oh, this part, yeah.
the plane. They want to
That's
copy
only
it.
if it's heading north.
Correct, only if it's heading north. If it's heading at an angle, then we have to use our formula that has the cos theta in
What
it.
if it's heading south?
South, I think, is okay.
The opposite.
No, south doesn't actually change anything. Because the only thing that matters is the vertical force. So it'll still be, the voltage will still be towards the west if it's taken off. Question? What's the area? It's the area you make when it moves. So for example, this pen, the area is, if you can picture the area I'm making in the space as it moves per second. I usually do it per second. So it's how quickly the area changes. So if this is very big, it means you have more voltage. If it's slow, you have less. And if you don't move it, now there's no more voltage. The alternative is to change the B. So this is where you have it not moving, but now move the magnet. So no magnet, magnet. No magnet, magnet.
Let the airplane hanging and move the earth.
Yes, you could do it this way too. A little harder, but you could leave the plane stationary and then take the earth and then just move it around it. Yeah. Interesting. Okay, did you write that down, Yusuf? Yeah. Right, let's have a look here at the questions.
Do you think it's possible to move earth? As in for
Earth
us?
is already moving.
Yeah,
No,
that's what I was going to say.
I mean,
I like to see my
Divert.
students learning my smart
divert.
answers.
Earth's,
Not the orbit.
yeah, like, I mean, if we like, I always thought about this. If we all stand on one side of the earth and then suddenly all of us jump together, or like put
The earth will just wobble, but you
Engines.
can't move it.
engines to move to get it out of,
If you put big enough engine.
like jet engines on all one side of the earth.
You know the answer to this. So here's your earth, and let's just, for our picture, say it's at rest, even though it's not. And here's our rocket, which we will send to the moon.
No.
No, just listen.
Okay.
So this mass is big, true. This mass is small. This has, we'd say it's at rest, and then this has velocity v.
Yeah.
So at the beginning, the momentum of the Earth plus the momentum of the rocket is 0. Afterwards, the Earth will move. We'll say its speed is x, so that would be mx. That's the momentum afterwards the Earth, plus the momentum of the rocket, mv. So x is equal to minus m over mv. So every time a rocket is launched into space, the Earth moves backwards a little bit.
Is that actually true? Or you
That
just
is
walk?
true.
Yeah.
This is
It's small because the mass of the rocket compared to the mass of the Earth is small.
So it is possible.
Yeah, so it is possible. So if many rockets fire, or as you suggest, Faisal, if you were to fire
Okay.
some gas
Yeah.
outwards, you would move the Earth.
Nice.
But you're limited by the mass of the Earth being so big.
You're giving him a flag, you'll be going to well,
Maybe-
get Arnold
maybe
closer
when
to the sun in summer.
Maybe when he grows up, he wants to be a Superman villain. And
yeah.
it's like, my plan,
Apocalypse.
yes, is to move the Earth 1 centimeter closer to the sun.
Global warming.
Our countries will die now.
Just so you know, the Earth's distance from the sun changes quite a bit throughout the year because it's not a circle.
I
So
know. Yeah, my thingy was about this first semester. The essay. The physics.
Yeah, you got
I've already forgotten about it. Yeah.
But you liked it.
Did I say that?
You gotta see.
You liked the body was really nice when the introduction and the thing. That's what you told me.
Oh yeah.
But you're like, I liked yours, it was interesting to read.
That doesn't sound like something I'd say. I said it.
Yeah.
I guess I was a different person back then. All right, we'll do these questions together now. Yeah, I think we'll.
And our lesson?
Finish it off here.
Start talking about the coursework.
No, not the coursework again.
No, just joking.
I hope so.
But I
It's due
wouldn't
tomorrow.
mind if
Can we do these questions now?
you want to, you can.
I would. No, sorry. I need to be clearer. Do these questions now, and shortly I will do the answers.
That's more like it.
Stay in there, Andrew. Hang in there. Can you try these questions now, please?
Okay.
In an actual notebook. Faisal, I know the physics is easy for you, or at least you think it's easy for you. What? But I
No,
don't
it's
think
not
I
that
don't
easy.
think this topic is super easy.
Yeah, I know.
So maybe you want to try and do these questions. And if you want something interesting, you could try the last one.
Oh.
Okay. Manhole.
Manhole is what's the circle on the ground
Manhole.
made of metal. On the street.
You can add one more letter and change the whole word.
What letter do you add? Never mind. I feel like I don't want to know, so I shouldn't ask. It's the circle on the ground. You lift it to go underground, where the turtles live. The Ninja Turtles. You know these turtles?
Teenage Mutant Ninja Turtle.
Yes.
Turtles coming out. 1, 2, 3, 4 turtles in a chimney.
No. I prefer the original, please. You know.
What's the letter that you add?
2.
Huh?
W and
Oh.
yes.
2 letters.
Yeah, I said.
What two letters?
1 letter. Woman hole.
No, not woman hole. What? No, bro.
What's the area of a cylinder?
Of a
Look at
cylinder.
Now, which question?
Weird things like
That's the volume. Why do you want the area now?
2 pi r plus pi r squared.
You're looking at the second one.
Yeah.
Now,
Is it an open cylinder?
picture a manhole cover for a second.
Cover. Yeah. Yeah.
Wait, it's just a cover.
Yeah.
Yeah,
It's not.
but
It's
it's-
just a circle.
It's a cylinder. It's a very short cylinder, but it's a
Yeah, because
cylinder.
they give you the thickness.
Yeah. So you lift
4
up
pi
you
r.
lift up the lid and you turn it and you drop it back down
Like it's hot.
like it's hot. Yeah. And the question is, as you're moving it, you get a current. Just like when you move the plane, you got a current. So the question is, what's the current?
0.
Interesting.
No. If you rotate it like without making it like if it's still like this, then it must be 0. 'Cause it's
You are 100% correct. So I tried to put in,
You tried to trick us,
yes.
but you tricked yourself.
No. But I was kind of hoping you wouldn't see it so quickly. Oh well. I guess that's good.
Lies.
Andrew fell for my trick, so I can...
What are you talking about? Wait.
The answer for number 2 is 0.
Why?
Because the manhole cover has to be moving vertically, like the plane. If it's simply rotated in the horizontal axis, there's no vertical force. The answer is 0.
Will they give us such a question?
No, because they'll only give you questions where you can calculate an answer. These are conceptual questions. Okay, on to number 3, so. I think you'll agree number 3 is not 0 now. Correct. Yusuf will explain to you. Why, please?
So one more piece like this. Like it doesn't move like perpendicularly to the Earth's magnetic field.
In the hand, which part is 0?
Thumb. No.
Because this part is 0. Yeah. You're missing this. This is missing because when Yusuf was saying, as you rotate it, you don't have this. You need to do this to get the current.
What if we sub the number? It still has the number.
Yeah. But you're subbing in the wrong numbers to the wrong formula. No? It's a trick question. Number 3 is not a trick question. You can try number 3. Lee, you are not finished. I don't believe you're finished. Are you working on this? Which one are you doing? Okay. Does anyone have number 3 yet?
What area do we take?
In number 3?
Yeah.
Good
the upper
question.
one.
Hint.
Right.
Hint.
Yeah.
Think of the airplane example.
What's the time?
Yeah, so how do we measure the area?
What's the time?
Time.
What's the time? UVATS.
Oh.
Dang!
I was actually going to do this question.
It's amazing how quickly you've forgotten Newton. If only you had some coursework recently on it to remind you of
Newton
it.
equals F.
Yeah.
Right between the lines.
I'm sure you always tell us to read between the lines.
I don't even know what that means, so sure.
The lines.
Newton F.
No, read between the lines. Yeah. The lines and you read between them.
I don't get it.
What is between those lines?
Nothing. It's empty.
It's the middle thing.
This kids cultural joke, I don't get it.
Oh, I went to the Pride Parade.
Good for you. Alright. Are you making a statement or in support?
I'm coming out of the closet.
Great. Great.
Why do you think I chose Ireland?
Yes.
I was taking a picture of this girl. She was wearing a police officer's costume.
And she was very good looking, as you described.
Yes.
She looked.
But
She's wearing like
considering the event,
it's like a
I don't
Halloween.
think she'll like boys.
It's a Halloween
But you have no chance.
costume thingy. So you can imagine what I was looking at. Then I was with my camera, so I was taking the pictures.
Yes, this story has a happy ending.
And then
She's not going to end up with you
she
arrested.
blew a kid
Oh.
Yes,
to the camera.
yes,
And then as she got closer,
yes.
and I saw her closer, turns out it's a him.
Yes, finally, some action. Some violent action.
Oh. Couldn't have happened to a better guy.
The world is drunk.
Yeah, that's a metaphor for life. When you think you're onto a winner, bam. Yes, number 3, is it?
Yeah.
This isn't about the time again, is it? What is number 3's question?
It could be like a weird question. But
Go on.
Is the S in UVATS 100 minus 2 or just 100?
The pipe, it's dropped like this, so it's 100. Not that it should affect the answer much anyways.
So I.
What's the A?
Wow.
9.81.
I.
Big A or small A?
The big I.
Oh, the big A. The area.
Yeah.
Yeah, what's the area?
You have
100.
Well, that's part of it.
100 times 2.
Yeah. The area is 100 multiplied 2. So the area is 200. Here, look. 2. 100. Yeah. Okay.
Question.
Do you have an answer for number 3? Give.
No, not yet.
Work it out. Work it out.
I can
Okay.
work it, but I can't work it out. No, serious question.
It's a serious question.
Yeah.
Okay, this isn't about LGBT,
No, it's about
gay
this.
pride. It's about physics.
Oh.
Forgot the Q.
Sorry, how
What is the
insensitive
Q? What
of
is the
me.
Q?
Queer.
You know, there was a sign, vegan and gay. Like,
What?
how worse can it get? No, really, question.
Thank you. Go on.
Why do we take area, not volume?
The formula has area in it.
Yeah, but why is it area?
Ask Faraday. What?
I cursed horribly. Like if it was volume, because it's moving.
No, you didn't curse Faraday.
Yeah, Faraday. Because if it was the volume,
You cursed his mother.
if it was the volume, it would make sense. But like the areas,
No, it shouldn't be the volume
it's
because
just flux.
yeah, but you only care about it being perpendicular. So the depth dimension has no importance. You know, so like with the plane, okay, everything is perpendicular. The force is perpendicular. It's no interest in the horizontal.
Oh, okay, now it makes sense. So if it was at an
I
angle.
think you owe Faraday's mother an apology.
Sorry. Remember, I also made this.
Yes, if it was at an angle, you look at the vertical component only. Okay, do we have an answer for number 3, please? Right, what answer do you have, Lee?
75?
3 point?
1.
Yeah. Did anyone else get that?
Yeah.
Good job, Juan. So the formula. Okay, what's the n here? 1. And what's changing here? Area. So what did I say the b was? 0.070 times 10 to the minus 3. And the time, did you work out the time using UVATS? The area is 200. 9.81, 100. Did anyone get the time?
4.5.
What is this one? 4.5. So in the end, your answer is You said millivolt. That makes me so happy. I remember in semester 1 when you were all, no, I don't want to say milli or micro. No, can't I just say 10 to the minus 3? Is that okay, teacher? I'm like, okay, fine. And now you said millivolt. That's so nice. That's the best present I could ever have gotten. Okay, can you write that one down, please? Can we go to the next one now? Okay, great. So, 4. Lee, you have number 4 done? Okay. Faisal, please do number 4. You haven't finished?
I'm doing fine.
Because 4's too hard?
It's too hard.
But it's
I
like the
know.
example I did.
Yeah. That's why I'm doing fine.
Oh, okay. Are you sure you can't do 4? I think you can.
I didn't say I won't, like I can't do it.
Oh, you just say you don't want to do it.
Yeah, I prefer doing fine.
Okay.
What's in 5 the rotating plane is small, 30 centimeter by 10 centimeter with a winding of them?
Yeah, that's the N. The N.
Okay.
In English, the word winding is a noun, and it means how many loops the wire goes around.
Wind the tape. Okay, so
I got 2 pi.
Go on.
Huh?
2 pi.
You got 2 pi. So you got about 6 volts. Now that's a bit big. Okay, well then that means Lee is wrong, which is amazing. Lee, what's the answer for 4?
Wait.
Are you sure? Because I get a different answer.
6.5.
Okay. Now I have 3 people with a different answer.
What do you get?
6.83.
Now you all heard that. He's sticking with 2.
2 pi?
2 pi.
Yeah, 2 pi is
Oh, yes.
6.28.
No.
Get back.
No.
Get back.
No. You are wrong. Okay. So I don't think I need to do number 4 because you did it. You beat Lee. He was the final boss. It took you months. Yeah. Okay. So I'm not going to do 4 because you were all successful. So 5 now. You can try 5 and then I'll do it.
The 50 and the 10.
I'll 30, 10, like this, and the magnets are here,
What do you mean?
and this is turning.
What do you mean with the winding of 10?
Winding.
Winding.
OMG!
Okay, never mind. Winding. Who said winding?
Faraday's mother.
One, 30, 10, magnet, north and south, like this. You need the 30 because you need the area.
Oh, the 5.
Are you doing 5, please?
Is this name a square?
30 by 10.
1 over f is tiny.
Correct. Yes, it is, yeah.
By plane, do you mean airplane?
Plane is a word for like a rectangle.
You don't know how many times.
Don't you, Fuang? Don't you?
Was your boyfriend was hot like me?
It's an F.
Andrew?
1 over f. equals
That's
T.
the T of the, I mean, I also think about that, but it's a T, so how many sample one second?
That's what the F is. But you can get the T from the F.
How many seconds for?
Oh, yes.
It's not related to,
Not related to us? No, it's not. But,
no, it's not identical,
no, it's not.
so it's not related to the X.
To the N?
N.
No.
N.
N.
N, the time.
The time and the N.
Yeah, that N.
Yeah, not related.
And I asking where the N.
The N is 10. That's what this word means. Yeah, means N.
First one is 0.
Yes. That's when it's this way. Is it 0? Because that's the plane is here. Yeah, because the force is in the direction of the field, which is what you don't want. You want the force and the field to be perpendicular. So the rotating force is now in the direction of the field. So yeah, so for the first case it is a 0, yes.
And then B.
So it's not B. I put B as 0.
No, I think you have them backwards.
Yeah.
On the plane.
Because you need to be
Yeah, you
thinking
have
about
them
the force.
backwards.
So when the plane is vertical and it's rotating, which direction is the force? This way.
Yeah.
Into the field, not perpendicular to the field. But when the plane is horizontal, the force, like the airplane, is up, perpendicular to the field as it should be. So in part A it's 0, and part B it is not.
It is B times area.
It's BA,
So
B-
what formula do you use for
not MBA.
A?
For which part?
A. Like that.
You don't use a
There's
formula.
no formula. It's like question 2. It's in the wrong plane. There's nothing happening.
What's N you mean?
Oh my goodness!
NBA.
Stop asking me what the N is. The N is
No,
10.
you said M. You said
No, I
NBA.
didn't say M.
Yes, that's why I was like, what? Yeah.
M is the mass of the magnetic field. Okay?
Can't trick me.
Yeah. You can measure them in Tesla or kilogram per elephant, whichever
Whoa.
unit you prefer.
Confused
NBA.
now? See what is time? What is the time take? Nice. To go from vertical to horizontal.
We speak English, okay? Leave me alone.
I speak American.
This is gangster speak, okay? You tell me what is time take, right? Thank you.
You can take time, but you can't time take.
It's good that we keep it real. How is number 5 going for you, Yusuf? This is the one you wanted to do. Oh yeah? Nice. Okay, so we'll do it now. Fuan? Yeah? Let's have a look at it. Yeah. Now, at the beginning, when the plane is vertical, the force is in the same direction as the field, so nothing is induced here. Okay, so the flux, which equals MBA, but it's really, this is MBA cos theta, isn't it? The formula has cos in it, isn't it?
Yeah.
Yeah, it's technically MBA cos 90. You're at the wrong angle. You have no flux here. Yeah. Isn't that the formula? MBA cos theta, isn't it? Yeah, yeah. That MBA will be for the second one. In this case here, it's exactly what you need. perpendicular, so that is NBA. And if you want to be technical again, it's NBA cos 0 this time. It's at the desired angle, it's not rotated. Okay. What is the N here?
10.
And the B?
5.
5. And the area? Okay, so that cancels that. 1.5 Webers. Part 3. What do I ask you for in part 3? Is it the time?
Yes.
The time is 1/4 T.
Yes.
Because it's only going a quarter turn. And that's 1/4 1 over F, which is 1 over 200 seconds. D. Now please, you have to be very careful here. This we don't use. We should use this. Can anyone tell me why I'm not using the N here? Yeah.
C?
Yeah, why have I not put the N in my calculation here? Why have I just dropped it out? Anyone know? No, it does. It does. Because I've already considered the N in the calculation earlier, the flux. I'd be including it twice. It'd be like me having NNBA in the formula. So I don't need it a second time. So the answer is 1.5 over 1 over 200. That's 300 volts. Yeah? No, it wasn't. No, it wasn't.
This is what I did. Oh, okay, now I know what I did.
This is good. The time between you asking me a question and realizing it's a silly question is getting shorter. It's good, you know. This is a year, and we'll measure that school year in days. And this is your response, your thinking time, your realization time measured in seconds. So at the start of the year, I don't know, how long until it took you to realize, wait, my question's silly?
More than 5
Yeah, well, you know, I like the way it's going. And what would be great,
slow but steady.
you slow but steady, but then
No,
if it goes underneath,
there's an inflection.
and then you can realize before you ask the question that you shouldn't ask the question.
What if it
And this-
reflects back upwards?
Oh yeah, no, we want to avoid that now. No, this is our goal. We want you thinking 1 second before you're talking.
Yeah.
But it's going in the right direction. I like the direction it's going. Good. Okay, so that's the tutorial on the induction. We'll start the next lesson in a moment. I just need to get a drink of water. It's very hot in here. I really hope they didn't put those heaters on. No.